Now we want to find and factorize non-monic trinomials. So the idea is, like, because it's non-monic, the value here in front of the x squared would be more than 1, or it wouldn't be 1. It could be it could be less than 1. It could be a negative number. It could be a positive number, but it's not 1. Monic means it's 1 in front of the x squared. Non-monic would mean it's anything other than 1. Now this just adds a little bit of complexity to the task, because we've got to consider that number in front is going to affect the number in the middle as well when we start to expand the bracket. So what we want to do is come down to the two brackets, but one bracket's going to have a number in front. So, or both will have a number in front of the x there in the two brackets. Now, what we've got to do here is firstly look and see if there's no common factor. Now, there's no common factor with any of them. So we've got a little bit of a trick we need to do. So what we want to do is use the idea of grouping them in pairs to solve this. So we want to end up with a situation where we're going to have a 3d squared with some term in terms of d, with another term in terms of d, and then a plus 2. Group them in pairs and come down to two brackets there. That's going to be our aim. So that's what we want to try and do. We're going to have a step there. We're going to have still factorise there. But the trick we need to do is have a look here at what numbers, if we get the product of these two, there is 6. Now what we want to do is be able to break it down into the factors of 6 and see which ones will add up to 5d in this case, because it's going to be positive. It's positive 6 because it's positive 2 there and a positive 3 there. So if we look at that, we get 1 and 6. We get 2 and 3. Now they're the only options because it's only 6. There's only 2 sets of factors there. Now, we want to decompose 5d into two numbers that will add up to 5d there, that are factors of 6. So the 2 and the 3 are going to be the ones we're going to choose. So if we get and write that as 3d there and 2d there. Now, hopefully you're getting to see, well, okay, because I've picked 3d and 2d, that adds up to the 5d. So that's not a problem. It's still an equivalent statement. But I'm able to write it in a way that I'm able to get a grouping of pairs and be able to start to factorize that. Because I can take 3d outside. We actually need to include our d outside it there because it's a common factor. So it'd be 3d, and we'll have a d plus 1 there, and we'll have a 2 factorized outside of a d plus 1 as well. So we can do that, and then we've got a common factor of d plus 1, and we'll have a 3d plus 2 there, and there's our factorization. Now if you expand that out, you'll get back to that. You actually go back to expanding it out, you get that, collect your like terms, you get back to that one. But there's the little trick we have to do to find that decomposition. We multiply the coefficient of the d squared and our constant term, and see then, well, if that's going to give us 6, what are the factors of 6 that are going to add to give us 5d? And it's going to add in this case because, well, it's going to be the sum. I shouldn't say add, it's the sum, because if that gives us a negative there, these could be negatives, and we'll see that with some other problems. But we'll be able to look and say, okay, how can we decompose it? We look at our factors there. We wanted the set of factors will add up to give us those, decompose it, and then we're able to solve as we need to. So that's the trick we're looking to do, and we can 3D and 2D can be set around any order there. It could be 2D plus 3D. It works better if it's 3D plus 2D because we're able to factorize that as a pair and that as a pair. Let's have a look at another example. 6p squared plus 19p plus 10. Again, no common factor, so we can't factorize anything straight out. So we look at the 6 and the 10, multiplies to give us 60. And then we're looking at two factors of a pair of factors of 60 that add to give us 19p. Again, it's all addition, so it's not too bad. So the factors of 60, if we look at it, 1 and 60, well, that'd give us 61p. That would be okay. That would be our 2 if it was that case. 2 and 30, 3 and 20, and 4 and 15. I think we've got all our factors. No, I think 5 goes in as well, and 5 goes into 60 12 times. There we go, that's the other factor there. And now I think we're pretty well covered. No, we're not. I've still got one more, 6 and 10. 6 and 10 work there as well. So, we're looking at two factors here that will add up to give us 19. So that gives us 16, 17, 19, 23. There's our two factors there. So that's what we need to split it up into. So we get 6p squared. And we can put, let's put 4 in there, 4p. I don't think it really matters. We can set it up either way and put them in any order, and we can still factorize in pairs. We can still get that. But we've broken 19p. This is called decomposing. 19p gets decomposed, breaking up into 4p and 5p. And we can decompose algebraic terms as much as we like, as long as it suits our needs. Let's factorize here. We've got a common factor of 3p. That will leave us with 2p. And so we can't take 3p out. We're going to take 2p out. Let's get that right. So we're going to take 2p out, and that will leave us with 3p in the bracket. And 2p times 2 will give us 4p. Then we can factor out a 5 there, and hopefully that will give us 3p. It's 5 3s are 15, so 15p, and 5 2s are 10. So it gives us the 3p plus 2. Notice how our brackets start to be the same as we had with our grouping in pairs, and we're able to say, well, that'll be 3p plus 2 and 2p plus 5. And there's our factorization. So there it is. It's nice. It works out nicely for us. Again, we could expand that out. We get back to that, which we can collect terms to get to that one. So there's our process to try and get that decomposition, to break it up in pairs there. So if we have a look at the next one, I've done a little preparation here. 6 15s are 90. So I've written our factors of 90 in their pairs. Now the problem with this one is that 6 15s are positive 90, but we get a minus 23. So the two of them have to be, well, really we're looking at a case, well, that's going to be minus 1, minus 90, minus 2, minus 45, minus 3, minus 30. So we have the options where these are the pairs that are going to give us positive 90, but will give us a sum of 23. So that's why I've set it up with a 6w squared, a minus there, with a plus 15. So we're looking for which pair still sums to give us minus 23. And I think you're probably looking at that one going, well, that's easy, minus 5 and minus 18. So that's what we're going to put in. So if we put a minus 18 in there, again, this order is just making it easy. I've just picked what I think would give us a nicer factorization. So when I've got 6w squared minus 18w, that will give us a give us a 6w out the front, because 6 goes in 18. So we get 6w out there. Let's get a pen, and we'll get a 6w out the front, and that will leave us with just w, and that will leave us a minus 3. And minus 5 factorizes out, and if we remember rightly, when we factorize, so we won't have a w there, we'll have a w there, but when we factorize a negative out of the positive, it's going to leave us with a negative 5, it's negative 3 there. So remember, what we want to do is get those brackets the same, and minus 5 times minus 3 will give us positive 15. So notice we get our nice brackets. It's working out nicely for us there. So it gives us 6w minus 5, w minus 3. And there's our factorization. Doesn't matter the order there because it's multiplication, so the order doesn't matter. So let's do one more example. This time we've got a 5y squared with a minus 11, which means the multiplication is 5 times minus 11 gives us a minus 55. Now, the good thing about this is there's not many factors for 55. 1, 55, 5, 11. But because it's minus, one's going to be minus, the other one's going to be positive. Now remember, like we did before, if we're looking for those numbers and they're going to break down to minus 6, the larger one's going to be negative. So it's either the negative there or the negative there, because when we're summing them, they're going to give us a negative 6. So the larger number is going to be the negative. So obviously it's not 55 and 1, it's going to be the minus 11 and 5, because minus 11 plus 5 gives us minus 6. So to do that, I think you're probably going to agree, hopefully you'll agree, that we're going to go and put a plus 5 there and put the minus 11y, so we can group them nicely and get some nice factorization. You get a 5y outside y plus 1, and we factorize minus 11 out there, and that's going to give us minus 11 times positive y would give us minus 11y, and minus 11 times positive 1 would give us the minus 11. Again, notice our brackets stay the same, and we're able to factorize the y plus 5y minus 11 out and get that in a separate bracket. Sorry, y plus 1 outside of it, and we get 5y minus 11 in that bracket. So there's our process of doing ones where we've got a non-monic trinomial. So we've got a number there. We multiply our two numbers, look at what are the factors going to be, and then see what those factors would give us for our middle term. So for the y term in y, and then we can break it down and solve using our grouping in pairs. So we'll have a practice next week of doing lots of these. As I said, you're going to do a lot of these over time. We really wanted you by the end of next week to have a great grasp of these. So we're going to practice lots, ask lots of questions next week. If you're not sure, but you've got to make sure you are really, not to stress it too much, confident with this work, because this is you're going to see lots of these as we go through.